Owning a house for many people is considered a big investment, but the cost of operating it can be an even bigger issue. In tropical climates, cooling alone can account for more than half of the electricity use of a house. This is an expenditure that people must incur in exchange for comfort. What if they spend this money elsewhere and still be comfortable? It is easy to imagine how you can save energy by replacing inefficient lamps or air conditioners, as the equipment will have to be replaced sooner or later when they stop functioning. But a house has a life of 40 to 50 years. Poorly designed houses that cannot provide shade from the sun or outside heat or allow the outside cool air to flow through will be something you cannot fix or replace easily. In video 1.8, we learned how to assess the life cycle impact of buildings. We shall now see how to analyze their overall cost, also referred to as the life cycle cost. It considers the various costs incurred during the life of a building. Let us try to understand what these costs are. These include capital costs for land acquisition and construction, expenses for energy, water, and other utilities, expenses for operation, maintenance, and repair, costs of replacement and renovation, residual value of the building, other costs such as the payment of interest on borrowed capital, taxes, etc. How do we account for the present costs and those projected during the life of the building? Overall cost assessment of building is particularly interesting when exploring solutions that must be compared in order to select the one that gives the minimum cost or maximum savings. In order to be able to add and compare cash flows that are incurred at different times during the life of the building, future costs need to be converted to present values by discounting them to the present. The interest rate used for discounting is a rate that reflects an investor's opportunity cost for money over time. A high discount rate means little importance given to future generations and vice versa. The overall cost is derived by identifying all annual costs over the building's life and discounting them to the present value. Such an analysis helps to estimate the overall costs of project alternatives and select the design that ensures the facility will provide the lowest overall cost of ownership consistent with its quality and function. Performed early in the process, it allows to refine the design and ensure a reduction in life cycle cost. A small incremental investment made while constructing the building can have long-term economic benefits. But who will bear the incremental investment in the context of developing countries? While conducting an overall cost assessment, we considered all the quantifiable costs and benefits. But what about the intangible benefits, such as enhanced air quality, good daylighting, better health and well-being of the occupants, improved productivity, etc.? Coronavirus has made us all aware of the relevance of buildings in stabilizing work and living environment, promoting and protecting the health of occupants and reducing the risk of infection. Also, the overall cost assessment does not account for the positive impacts of well-designed buildings on externalities such as depleting natural resources, climate change, and environmental degradation. There is a global acknowledgement that the buildings and construction sector can contribute significantly to achieving climate goals. Public climate finance is seen as a powerful tool to help meet the incremental investment needs of developing countries by creating attractive conditions for scaled up investments in low energy and low carbon buildings. Here are some examples. The Program for Energy Efficiency in Buildings, or PEEB, combines financing for energy efficiency in large-scale projects with technical assistance through policy advice and expertise for building sector professionals. The German Development Bank, KfW, is supporting the construction of energy efficient residential buildings with low energy consumption and reduced carbon emissions by offering incentives in the form of favorable interest rates and interest subsidies. The French Development Bank, AFD, is providing a credit line to national housing banks for financing the construction and acquisition of energy efficient housing units whose eligibility depends on the social, energy, and environmental performance of buildings. To summarize, here are some of the benefits of conducting overall cost analysis by professional developers. They can make the right choices during the design phase to optimize them and consolidate. They can initiate a continuous cycle of improvement on new projects based on feedbacks and lessons learned from the past operations. They can justify any incremental costs by the benefits accrued over the time, representing several times the initial overcost. They can monetize the external cost to invest with the full knowledge of the facts and make choices that reconcile economic, social, and environmental benefits.